We're going to learn how to move them from one form to the other. There's 3 different forms for lines, so we're going to learn to convert them from one form to the other. Okay? So our first section is on the slope. So as you learned last year, the slope is the steepness of the line. So it's how steep a line is. So if it goes over gradually like this is a more gradual line. It has a different slope than a line that goes up more to pitch. And obviously, negative slopes are ones that go downhill. So it's rise over run. The formula, which you might want to make note of, is change in y over change in x. You just simply subtract your y's and then put that over subtracting your x's. Some of you guys in Mr. Dobez's class talked about delta y. This is just a notation for it. We're not talking about the delta fraternity house. We're talking about the delta symbol. The Greek symbol stands for change. The word delta means change in. So this can be read change in y over change in x. You'll use that kind of notation a lot when you get to calculus. Okay, so we're going to use that formula for the slope and just practice finding the slopes of both for all 4 of these. I'm going to do a couple. I would recommend, actually, if you think you know what you're doing, you might want to stop the video, try them on your own, and then start up the video when you're done and see if your answers match mine. So I'm going to subtract my y's, and it doesn't matter what order I go in. I could do 5 minus 4, and if I'm going in this direction then I want to do negative 3 minus 2. So if I do that, 5 minus 4 is 1, and negative 3 minus 2 is negative 5, and I can't simplify that, so that's my slope. I could have, I'm not going to do this every time, but I certainly could go in the opposite direction. So I could do 4 minus 5, but then I have to go in that same direction. So I have 2 minus negative 3. So that becomes negative 1, and that becomes a positive 5. And as we talked about in one of the other units, as long as there's only one negative symbol, it doesn't matter if it's positive 1 over negative 5 or negative 1 over positive 5. As long as there's only one negative symbol, it doesn't matter. They're equal if you attach that negative to the 5 on the bottom or to the 1 on the top. Either one, it doesn't matter. So when we're talking about rise over run, if it were listed this way, I would go up 1 and I would go backwards 5. For this one, I would go down 1 and over 5. So can you see how that's going to get us to the same direction? You might want to play around with that with graphing. So for the next one, I'm going to do 3 minus negative 2 all over 1 minus 0. So this becomes, that's plus plus, so that's 5 over 1, and I can simplify that just to 5. But for graphing purposes, it's actually easier because we're looking for rise over run, so this would be up 5 over 1. So I would go up 5 and I would go over 1, over positive 1. Okay? So the last 2, so I'm going to do 4 minus 4 over negative 2 minus 0. Well, 4 minus 4 is 0, and this is negative 2, and 0 over anything is 0. So we're going to talk a little bit about that in a minute, what a 0 slope means, but just remember that slope is 0. And this one over here, negative 3 minus 6 over 1 minus 1. So I get negative 9 over 0. And hopefully you guys remember, you can never divide a fraction by 0. You can never have 0 in the denominator. So this is what we're going to call undefined. And we will talk about what that 0 and undefined slope means in a little bit. All right, so now that you know how to find, actually we're going to talk about it right now, now that you know how to find the slope of lines. So there are 2 special kinds of lines. There are horizontal and vertical. So a horizontal line is a line that goes like along the horizon. A vertical line is one that goes up and down. A horizontal line has a slope of 0. So the way that I usually teach that is so if I have a grid, my slope, you guys all know I'm a skier, right? So when I ski, there are many different kinds of slopes. So when I taught my daughter to ski, this was her skiing on this, she skied on a easier slope. Okay, my son and I, we like the expert slopes. Okay, but and then down at the bottom of the hill, actually, let's talk about that 0 slope. So down at the bottom of the mountain, when you're pushing yourself along the bottom, I can still ski on that, right? I can still go on it. That has a 0 slope. That's more like cross-country skiing. So you can have a zero slope. It means that there's just no pitch. There's no pitch up, or these are all negative slopes. There's no pitch down. So a zero pitch is a flat line, okay? It's not going up or down. Now, in contrast to that, we have vertical lines. So this would be like a cliff in reality. And that is one thing, you know, I might be able to ski, I doubt it, but I might be able to ski on a trail that's like this. But nobody can ever ski on a trail that goes vertically up and down. That's a straight cliff. There is no way gravity would let you hold on to the side of that cliff if it were perfectly straight up and down. So this has an undefined slope. This is undefined. So keep straight, because we're going to talk about undefined lines as vertical lines, and then we're going to talk about horizontal lines that go across. So this is horizontal, this has a zero slope, this one is undefined. Okay? So back to our lesson. So a horizontal line, like I said, has a zero of slope, and a vertical line is undefined. And the equation for a horizontal line always begins with just y equal to some number. So, for example, y equal to 5 or y equal to -2. A vertical line has the equation x equal to some number, so I could say x equal to 5 or x equal to -1. I could also have x equal to 0, and I could also have y equal to 0. You can have a vertical line or a horizontal line that goes along the axis. And let me just explain kind of where this comes from. So if I have a coordinate system, and let's pick a bunch of points. I'm going to do a bunch of points like here, and let's say they are all at 3. So this point maybe is -5, 3, and this point maybe is -2, 3, and this point perhaps is 0, 3, and let's say this one is 2, 3, and this one maybe is 5, 3. So hopefully you realize that all of those, because they all have the same y quantity, they make a horizontal line, and they all have, it doesn't matter, x can be anything but y, that's why our equation is y equal to some number. So this equation here would be y equal to 3, because I really don't care what x is. This line y equal to 3 is actually made up of an infinite set. That line keeps going forever and ever and ever, and it has an infinite number of points on that line, and they all have a y coordinate of 3. And likewise, a vertical line, a line that goes up and down, will all have the same x value. Okay, so make sure you keep those special lines in mind, horizontal and vertical lines. The other key that I want to say, the other star point I want you to make, is there is only one variable. Okay, oops, I didn't spell that right. So there's only one variable. So make sure all the other lines have y equal like mx plus b. So there's both a y and an x in it, but these two special lines only have either just a y or just an x. That way you know that you're dealing with one of the two special lines. Okay? So there are 3 types of equations that we're going to learn. So you probably learned these last year. Y equals mx plus b is our slope-intercept form. This m right here, stands for your slope. So that rise over run, those slopes that we calculated a minute ago. So when we calculated all these are all m values. M as in Mary. And the y-intercept is our b. Our y-intercept is, when we go to graph, that's where I start the graph on the y-axis. If you have trouble graphing, please let me know. And then our point slope form, that's what we use when we know one point and the slope. So if the information that I have to work with is that I have at least 1 point, sometimes we have 2, but I have at least 1 point and the slope, so those are key. You have to have a point and a slope, then you use your point slope form. So the point is going to be x1, y1, and our m is our slope as always. And standard form, what I want you to notice about this is that the x and y are together. They are together. Really important. Because we're gonna be able to go from this form to this form to this form, and we can switch all around. Actually, generally we go from the middle form up to slope-intercept form and then down to standard form. But what I want you to notice here is that the x and y together. In slope-intercept form, the y is all alone. So we're going to talk about that in the second video when we get to solving. So, like I said, you can be given any kind of information. So all of these right here, and we will practice some of these, you need to be able to, given whatever information you're told, can you then either put it in some equation of a line. So if we're given a point and a slope, the first two I hope are kind of easy. If we're given 1 point and the slope, then that would be our point slope form. So that's where we would put it in y minus y1 equals m times x minus x1, and we will practice one of those. If we're given a point and the y-intercept, that's a little trickier. There's a couple ways you could do that. If you're given a point and the y-intercept, well, if the y-intercept, like if I'm given that the y-intercept is 5, isn't that a point? So if I'm told the y-intercept is, for example, 5, then I know that I have the point 0, comma 5, right? Because if I go over here to my y-axis, and I tell you that this 5, 1, 2, 3, 4, 5, is the y-intercept, well, that point is 0, comma 5. So then I could use my original point and this point to find my slope. Okay? And we're going to do that in this next example when we do point and point. So if you're given 1 point and then you know another point, we're going to do that in just a second. Okay? So let's say we have a point and a point. So what are our steps? So actually, I'm going to open this up to the second page. So I have an example down here, and then I'll add our steps as I do this. So, if we're given 2 points, the first thing we need to find, or we can find, is our slope. So that's going to be our step 1. So our slope, and we're going to use our formula, that's y1 minus y2 over x1 minus x2, or delta y over delta x. And again, this doesn't matter. I could have done y2, if you already learned it as y2 minus y1, as long as you do x2 minus x1. As long as the numbers go in the same order, it's fine. So I'm going to do 5 minus negative 6 over 3 minus 2. And that becomes 11 over 1. So my slope is 11 over 1. So our first step, let's go up to our steps. Our first step is to find slope. Then once you know your slope, then we can use 1 point. So we want to use 1 point and the slope. So use 1 point, and it doesn't matter. I could have picked the first point or the second point, either one. So use 1 point and slope in our point slope formula. Okay, so that's one of the formulas, or point slope form. That's this middle form, y minus y1 equals m times x minus x1. If you want to write that here, y minus y1 equals m times x minus x1. Okay, so let's go, and these are the 2 steps, sorry, 1 and 2. Okay, so let's go down here. So now I'm gonna pick the first one. It really doesn't matter. So y minus 5 equals 11 over 1 times x minus 3. So for now, this is in point slope form. So sometimes you could be given 2 points and it says leave it in point slope form. If it says leave it in point slope form, this is point slope, then you're done. We will, in the second video, learn how to take this and put it into slope-intercept or into standard form. But for now, I just want you to get it into one of the 3 forms. Okay, so that's how to deal with it if you are given 2 points, find the slope using both points, and then use one of the 2 points. Okay, 2 more. So what if I am given that I have, a point, and then I want it to be parallel or perpendicular to another equation. So for example, down here, you might be given this. It might give you a point saying I want the equation of a line that goes through this point that is parallel